billions of stars, silent clouds of dust and endless light, our galaxy is a calm ocean in the darkness of space. Tonight we'll share 100 soothing facts about the Milky Way to help you relax and drift into sleep. If you enjoy this journey, please like, subscribe and share, and tell us in the comments, when you look at the night sky, what makes you feel most at peace. Thank you for being here now. Let's begin. The Milky Way is a spiral galaxy filled with hundreds of billions of stars, each glowing with its own quiet light. Its disk stretches for about 100,000 light years from edge to edge, turning slowly in a rhythm that takes hundreds of millions of years to complete a single rotation. Its spiral arms wind gently outward from the central bar where countless stars cluster around a dense and mysterious heart. At the very center lies Sagittarius A, a supermassive black hole with a mass of several million suns invisible, but shaping everything around it through gravity. The Sun sits far from this central hub, roughly 27,000 light-years away, moving along its path through the Orion Arm at a calm pace of more than 200 kilometers per second. Yet even at that speed, it takes about 230 million years for the Sun to circle the galaxy once. The Milky Way's luminous disk is surrounded by a vast halo of old, faint stars and dark matter, extending well beyond the visible edge. The halo is almost spherical and sparsely populated, containing ancient globular clusters that are among the oldest objects known. Within the disk, dust and gas form a thin layer that weaves between the spiral arms, creating regions where new stars are born in soft nebulae of hydrogen and other elements. Star formation happens slowly and quietly, with gravity drawing together clouds of gas until they ignite in fusion and join the galaxy's glow. Some regions are calm and diffuse, while others shimmer with blue young stars that reveal where recent birth has taken place. The Milky Way also carries scars of its past, absorbing smaller galaxies that wander too close and leaving trails of stars in its wake. The Sagittarius dwarf galaxy and the Magellanic Clouds are among the nearest of these companions, moving in intricate orbits that will one day blend into the Milky Way's mass. Beyond the visible arms, faint streams of stellar debris mark where older collisions have already merged. The galaxy's total mass is immense, much of it unseen dark matter whose gravity holds everything together. Without it, the stars would fly outward into the void, but the invisible matter forms a vast cocoon that keeps the system stable. Inside this structure, gas cycles through life and death. When stars end their lives, they release elements forged in their cores, enriching the interstellar medium from which new stars and planets arise. This slow recycling gives the Milky Way its chemical diversity, allowing carbon, oxygen and iron to spread gradually through space. The Sun itself was born from such enriched material, carrying traces of countless earlier generations. Over immense time, the galaxy has changed shape, thickening and settling, as waves of star formation flare and fade. Some stars orbit far above and below the main plane, their motions revealing the galaxy's layered history. Others travel in near-perfect circles, maintaining the calm rotation that defines the disk. Interstellar dust, though thinly spread, softens starlight and paints the band of the Milky Way across the night sky with mottled darkness. From Earth, this band appears as a pale river of light, though it is in truth the collective glow of billions of distant suns. Each point of light hides planetary systems, gas clouds, and silent clusters bound together by gravity. The Milky Way's environment is gentle on cosmic scales, existing within the local group, a small collection of galaxies including Andromeda and Triangulum. The Andromeda galaxy drifts toward the Milky Way and will eventually merge with it in several billion years, forming a new larger galaxy in a slow and graceful union. Around the galaxy's outskirts, high-energy particles flow outward in cosmic rays, remnants of supernovae and other powerful events. These particles drift through magnetic fields that thread the Milky Way like invisible lines, shaping how gas and dust move through space. The galactic magnetic field is subtle but pervasive, a quiet force that influences how stars and clouds evolve. In certain regions, dense clusters like the Pleiades or the Omega Centauri glimmer with hundreds of thousands of stars packed tightly together. These clusters orbit the galaxy as relics of ancient times, reminders of its early formation when the universe was still young. Many of the oldest stars are faint red or yellow, small and steady, capable of burning for trillions of years. Others are bright blue giants that live short, intense lives before collapsing into remnants such as neutron stars or black holes. These remnants, scattered through the disk, add to the galaxy's complexity without disturbing its overall calm. Gas flows inward and outward in long cycles balanced by gravity and pressure. The Milky Way's thin disk is just a few thousand light-years thick, while its diameter extends far beyond what any telescope can easily capture. The stars within it form a pattern like a vast pinwheel, though its spiral arms are not solid structures but regions where density waves compress gas and trigger new formation. Between these arms lie quieter areas where older stars drift through near-empty space. In every direction motion continues, yet from our perspective the galaxy appears timeless and still. The light that reaches Earth from the far side of the Milky Way has been travelling for tens of thousands of years, so even as we gaze upon it we see the past. This central bar stretching across the middle holds densely packed stars that orbit in complex paths, guided by the black hole's gravity. Around this heart clouds of gas glow with infrared light hidden to human eyes, but visible to telescopes like Spitzer and Gaia. These instruments have mapped billions of stars, revealing that the Milky Way is slightly warped, its edges bent like a slow-moving wave. Such distortions are thought to come from past gravitational interactions with other galaxies or satellite companions. Despite these disturbances, the overall structure remains stable on timescales far beyond human comprehension. The Sun's own journey through the galaxy carries it through regions of differing density, sometimes near star-forming clouds, and sometimes through vast voids. Every few 100 million years, the solar system crosses one of the spiral arms, where the density of stars and dust is higher. Yet even this passage happens gently over spans of time so long that no single civilization could witness a full orbit. The Milky Way contains not only visible matter, but also an enormous reservoir of dark energy and dark matter that define its motion in the larger universe. It moves together with Andromeda and other members of the local group toward the Virgo cluster, drawn by the combined pull of distant structures. From the outside, if one could look upon it, the Milky Way would appear as a soft spiral of pale gold and blue glowing quietly in the dark. Within it, countless worlds orbit countless suns, most unseen and unknown. Across all this expanse, the galaxy remains in delicate balance, each motion contributing to the harmony of the whole. It is a system both ancient and alive, where light and gravity weave an endless pattern of renewal. The Milky Way drifts through space as part of a larger cosmic web bound to its neighbours by gravity that stretches across millions of light years. Around it float small satellite galaxies such as the Large and Small Magellanic Clouds, glowing softly with their own populations of stars and gas. These companions orbit the Milky Way like faint attendants, and their gravitational pull creates delicate tides of material along the galaxy's outer rim. Over time, such interactions help feed the Milky Way's evolution, drawing in new matter while dispersing old clouds of dust and gas. Every interaction leaves subtle imprints in the form of stellar streams, ghostly trails that wrap around the halo. Some of these streams are remnants of long-absorbed galaxies, their stars now indistinguishable from the rest. The galaxy's shape is not fixed but constantly refined by these motions expanding and breathing over hundreds of millions of years. Inside the galactic disk, density waves ripple through the gas, compressing it into lanes of new star formation. These waves move like traffic patterns through the spiral arms, guiding where stars are born but leaving behind wide gaps of relative calm. The most active regions are filled with nebulae that glow in the light of newborn suns. The Orion Nebula is one of the best-known examples, a cradle of stellar birth, visible even from Earth's night sky. Within it, gravity gathers hydrogen atoms until the pressure and heat become sufficient to ignite nuclear fusion. Each new star adds a flicker of brightness to the galactic canvas. Over time, such regions disperse their gas blown away by stellar winds, leaving clusters of young stars that slowly drift apart. The Milky Way's life is one of balance, where destruction and creation coexist quietly. Massive stars burn through their fuel rapidly and end their lives as supernovae, scattering heavy elements into the surrounding space. These explosions, though violent, are essential for spreading carbon, oxygen, and iron materials necessary for planets and life. The debris cools and forms new clouds, continuing the long cycle of renewal. Smaller stars like the Sun live much longer, glowing steadily for billions of years before fading into white dwarfs. Together, all stars contribute to the gentle background light that defines the galaxy. The galactic center, though hidden by thick clouds of dust, is alive with energy. Observatories using infrared and radiolight have peered through the veil to reveal clusters of hot stars orbiting the supermassive black hole. This region emits powerful radiation as matter spirals inward, heating to extreme temperatures before crossing the event horizon. Despite this activity, the overall pace is unhurried, measured in millennia rather than moments. The black hole itself does not devour the galaxy, but quietly influences its structure, helping to anchor the orbits of nearby stars. Around the central bulge, stars follow complex paths that intersect and twist, creating a glowing heart that slowly rotates as a single unit. Moving outward from this dense hub, the spiral arms become more distinct, rich with gas dust and young stellar clusters. The Perseus arm, the Sagittarius arm, and the Scutum Centaurus arm are among the major features, each stretching thousands of light years and housing billions of stars. Between them lie interarm regions, sparse and serene, where older stars drift in relative isolation. The galactic disk itself is slightly warped, curving upward on one side and downward on the other, a result of gravitational tugs from its satellites. This warp gives the Milky Way a gentle asymmetry, like a wave frozen in motion. The thin and thick disks differ in age and composition, with older stars occupying the thicker region above and below the main plane. These differences preserve the memory of the galaxy's early formation, when collisions and mergers shaped its current form. Above the disk extends the galactic halo, where globular clusters hang like ancient lanterns in a vast dark sphere. Each cluster holds hundreds of thousands of stars bound tightly by gravity. Their light is faint and steady, unchanged for billions of years. These clusters orbit the galactic center on long looping paths that trace the Milky Way's invisible mass. The halo also contains streams of dark matter that cannot be seen directly, but reveal their presence through the motion of stars. Within the disk, clouds of molecular hydrogen drift and collide, forming filaments that stretch for hundreds of light years. Inside these filaments, density increases until new stars begin to form, often in groups. The process is slow and balanced, taking millions of years to complete. Between the stars, dust grains composed of carbon and silicates float through space, scattering starlight and creating the galaxy's characteristic glow. These grains are tiny but essential, serving as seeds for planets and helping regulate temperature within clouds. As stars evolve, they shed material back into space through stellar winds, ensuring that nothing is wasted. Even the remnants of supernovae contribute, forming nebulae that shine for thousands of years before fading into darkness. The Milky Way's rotation curve reveals that most of its mass is invisible. The speed of stars in the outer regions remains higher than expected, implying the presence of a vast halo of dark matter. Though undetectable by light, this substance provides the gravitational glue that keeps the galaxy intact. Without it, the spiral arms would disperse and the stars would drift apart. Astronomers continue to map this unseen structure using observations of star motions to infer its extent. Beyond its edges, the Milky Way merges gradually into the intergalactic medium, a thin and cold expanse of gas that connects all galaxies. In this environment, the Milky Way travels with the local group, heading slowly toward Andromeda. The two galaxies are expected to collide in about 4 billion years, forming a new elliptical galaxy, sometimes called Milkomeda. The encounter will not be destructive on a stellar scale, for the distances between stars are vast and most will pass unharmed. Instead, gravity will reshape their orbits, creating new patterns of light. Even now, faint tidal bridges of stars link the Milky Way with nearby companions, precursors of the greater merger to come. The Sun during this process will continue its quiet orbit, likely unaffected by the distant collision. The scale of time and distance in the Milky Way defies everyday experience. Light itself, though swift, needs tens of thousands of years to cross from one side of the disk to the other. The signals from distant stars arrive, carrying stories of their past states, allowing astronomers to reconstruct the galaxy's evolution. Instruments like Gaia have charted billions of these stars, measuring their positions and motions with exquisite precision. From this data emerges a portrait of the Milky Way as a living, rotating structure, constantly reshaped by gravity, yet serene in its overall rhythm. It is both dynamic and peaceful, a system where vast energies coexist with stillness. The galaxy's light reaches every night sky on Earth, a reminder that our world belongs to something immeasurably larger. Its soft shimmer invites reflection, not urgency. In every sense, the Milky Way is an emblem of cosmic continuity, a gentle spiral of matter, light and time that endures far beyond the span of any single star or being. Within the Milky Way order arises from apparent chaos shaped by the steady influence of gravity acting over incomprehensible spans of time. The galaxy's stars do not move randomly, but follow coherent paths that together form a slow, harmonious rotation. Each orbit is affected by the combined pull of billions of others, producing a balance that holds the system together. The spiral arms that define the Milky Way are not permanent structures but passing patterns, density waves moving through the disk and compressing clouds of gas as they go. Where these waves travel, new stars flare into being, lighting the arms in shades of blue and white. Between the arms lie older stars, yellow and red, drifting in quieter orbits and adding warmth to the galactic glow. The gas that fuels these cycles of creation comes from many sources: the remains of dying stars, interstellar clouds, drawn in from the galactic halo, and filaments of cold hydrogen that drift between galaxies. Over billions of years, this gas has been gathered and reused countless times, forming and reforming into new generations of suns and planets. In this way, the Milky Way is a continuous workshop of renewal, where matter never truly disappears but changes form in gentle succession. The central bulge of the galaxy glows with ancient light composed mostly of old stars that have burned quietly for billions of years. These stars are densely packed, orbiting the unseen black hole in complex trajectories that resemble the flow of water around a drain. In the midst of this brightness, occasional bursts of activity mark regions where infalling gas feeds the black hole, releasing energy that radiates across space. Around this central region, the bar structure stretches outward, funneling material from the inner arms toward the core. This bar rotates slowly, shaping the orbits of surrounding stars and influencing how the spiral pattern extends through the disk. Beyond it, the arms unfurl in sweeping curves, vast rivers of starlight and dust that define the galaxy's familiar form. From above, the Milky Way would appear as a glowing whirlpool, its light fading gradually toward the edges, where the disk thins into darkness. There in the outermost regions, stars are few and far apart, moving at nearly the same speed as those closer, in a clue to the presence of dark matter that holds the galaxy's mass together. Astronomers have learned that the Milky Way's dark matter halo is much larger than the visible galaxy, stretching hundreds of thousands of light years into space. It is this unseen structure that gives the galaxy its stability, allowing it to persist through cosmic interactions and collisions. The halo also contains ancient remnants of smaller galaxies torn apart long ago, their stars now part of the Milky Way's extended family. These relics orbit silently, tracing elliptical paths that loop far beyond the galactic plane. Some globular clusters follow similar routes, moving like gentle sparks around a central fire. Each cluster holds stars that formed when the universe was still young, their compositions revealing the earliest chemistry of the cosmos. As the Milky Way evolved, new waves of star formation built up its thin disk, adding layers of complexity and color. The younger stars are found within the spiral arms, often accompanied by clouds of glowing gas. These bright regions are nurseries where life begins for suns and planets alike. The radiation from hot, massive stars illuminates nearby clouds, creating diffuse nebulae that shimmer in pink and violet hues when seen through telescopes. Such regions are short-lived, lasting only a few million years before the stars disperse their birth clouds with strong winds. Yet across the galaxy, countless others take their place, ensuring the rhythm of formation never stops. Between these busy zones lie calm expanses where only faint interstellar gas drifts illuminated by the collective light of distant stars. Here, dust grains form thin veils that scatter and redden the light, creating the soft glow that makes the Milky Way's band across the night sky appear mottled. These grains are the raw material for planets, and in regions where gravity gathers them into disks around young stars, new solar systems slowly take shape. It is from such a process that our own sun and planets emerged about 4.5 billion years ago. The Milky Way, therefore, is not merely a background of stars, but a cradle of worlds, each following its path within the Great Rotation. Over immense time, these orbits trace elegant spirals that change so gradually no eye could perceive the motion. Even the sun's path is part of a slow oscillation, rising and falling, gently through the galactic plane as it travels around the center. Every few tens of millions of years it passes slightly above or below the main disk, like a buoy moving on a calm sea. This motion affects how the solar system encounters clouds of interstellar gas and cosmic rays, linking our local environment to the larger structure of the galaxy. Cosmic rays themselves are born from the deaths of massive stars' particles, accelerated to near the speed of light that stream outward through magnetic fields. These fields thread the Milky Way like invisible currents, guiding charged particles and shaping the structure of the interstellar medium. Though imperceptible, they help organize the motions of gas and dust, influencing where new stars can form. The galaxy's magnetic field also interacts with the solar wind, creating a complex boundary where the influence of the sun fades and the interstellar space begins. Beyond this boundary lies the true realm of the Milky Way, filled with diffuse plasma, faint radio emissions, and distant echoes of ancient explosions. The balance of energy across the galaxy is delicate. Starlight warms the dust and gas, while cooling processes allow new clouds to condense. Over time, this equilibrium ensures that no single region dominates, preserving the Milky Way's long-term stability. It is a dynamic system, yet one that feels timeless from a human perspective. The galaxy's past stretches back nearly the entire age of the universe, and its future extends far beyond what the human mind can grasp. When the Sun completes its current orbit, 200 million years will have passed on Earth, and continents will have shifted beyond recognition. Still, the galaxy will look much the same, its spiral arms intact, its stars continuing their silent dance. The Milky Way's endurance lies in its immense scale, and the steady laws that govern it, gravity, light, and motion, all intertwined in endless harmony. Each star, each atom of dust contributes to the quiet order of this vast system. From our small place within one of its arms, the view of the galactic band overhead serves as both a reminder and a comfort that even in the boundless dark there is structure, rhythm, and light enduring without haste. Across the Milky Way, countless stars evolve through stages that together define the galaxy's continuous transformation. The younger stars emerge within dense molecular clouds, where temperatures are so low that atoms gather quietly until gravity overwhelms resistance. Inside these clouds, the faint glow of infrared light reveals clusters of forming suns still wrapped in dust. As these stars ignite, their radiation clears the surrounding gas, leaving behind sculpted shapes known as emission nebulae. Some regions display intricate filaments of gas and dust, such as the Eagle Nebula, where towering pillars mark the slow process of creation. Each newborn star represents the fusion of hydrogen into helium, a reaction that releases energy and light, maintaining the gentle balance that allows galaxies to shine for billions of years. The Milky Way hosts every stage of stellar life simultaneously: birth, maturity, and decay, spread across its vast structure. Massive stars burn bright and brief, ending as supernovae whose shock waves trigger new generations of formation. Smaller stars live in calm endurance, fading only after tens of billions of years. The galaxy's visible light is dominated by middle-aged stars like the Sun, whose yellow glow stabilizes the disk's soft radiance. Between these sources, dark lanes of dust trace the spiral arms, absorbing and scattering light into patterns that create the mottled texture seen from Earth. These lanes contain the raw material for future suns and planets, maintaining the cycle of renewal that defines the Milky Way's rhythm. Near the galactic center, conditions grow more extreme. Their gravity pulls stars into faster orbits around the supermassive black hole, whose presence is known not by direct sight, but through the speed of stars moving under its influence. Surrounding this core, clouds of ionized gas radiate energy across many wavelengths, forming a complex interplay of heat and motion. Yet even here, amid the density and force, the balance remains steady. The black hole consumes only a small fraction of nearby matter, enough to keep it active but not disruptive. Its immense gravity binds the inner region together, ensuring that the central bulge remains intact. The Milky Way's bar structure acts as a bridge between this inner hub and the spiral arms, guiding gas inward in long, slow flows. These inflows sustain star formation near the center, where the oldest stars coexist with newborn clusters. In contrast, the outer disk is tranquil, marked by wide intervals of empty space between scattered stars. Here the galactic plane thins until it merges with the halo, where density drops and the influence of dark matter becomes more pronounced. Within the halo, globular clusters orbit like ancient companions, their stars aged and chemically simple forged when the galaxy itself was still forming. These clusters serve as records of early cosmic history, their light travelling across time to reach modern instruments. Their stars are poor in heavy elements, showing that they were born before generations of supernovae had enriched the galaxy's composition. Deeper within the disk, by contrast, stars like the Sun carry the accumulated elements of billions of past lives. Iron, carbon, and silicon, all products of earlier stars, form the building blocks of planets and ultimately life. In this way, the Milky Way story is one of continuity, where each end gives rise to another beginning. Even the space between stars, called the interstellar medium, is not empty. It contains diffuse gas dust grains and magnetic fields that weave through it like invisible threads. These components interact in subtle ways, shaping how energy moves through the galaxy. Cosmic rays, high-energy particles born in distant supernova, travel through this medium and influence its temperature and chemistry. The balance of heating and cooling determines where new clouds will form, and over millions of years the pattern of star formation drifts from one region to another. Observations from missions such as Gaia Spitzer and Herschel have mapped these dynamics with increasing precision, revealing that the Milky Way's spiral structure is not fixed but alive with motion. Stars orbit the center at varying speeds depending on their distance, but the overall rotation remains remarkably coherent. This motion, combined with gravitational interactions, produces a slow pulsation through the disk, a galactic heartbeat that regulates its evolution. The galaxy's surface brightness, when viewed from afar, would appear as a gradient of gold and white near the center, fading into cooler blues along the arms. Embedded within this glow are darker dust regions that conceal new worlds forming around young stars. These systems take shape over tens of millions of years as particles collide and merge into planets. In the Milky Way alone, astronomers estimate there are more planets than stars, many orbiting quietly in stable configurations. Most remain unseen, their faint light lost among the brilliance of their suns, yet they add to the galaxy's quiet abundance. Some are frozen, others molten, and a few may carry the right balance for life, though the distances between them make any connection purely theoretical. On a grander scale, the Milky Way interacts with its neighbors through gravitational tides that extend for hundreds of thousands of light years. The Magellanic Clouds, though smaller, send streams of gas that wrap around the galaxy, fueling future generations of stars. These streams are faint but persistent, forming bridges that link the systems in a slow exchange of matter. In the distant future, the Andromeda Galaxy will approach and merge with the Milky Way, reshaping both into a new, larger elliptical form. This merger, though immense in scale, will unfold over billions of years and will be serene when viewed at the pace of cosmic time. Stars will pass each other unharmed, and their orbits will gradually settle into a new equilibrium. The night sky seen from any surviving world will fill with new constellations, and the combined light of both galaxies will form a single glowing core. Even then, the underlying patterns of gravity and light will remain unchanged, preserving the continuity of the cosmic order. Back in the present, the Milky Way's appearance from Earth remains one of quiet wonder. On a clear night, far from artificial light, the galactic band arches from horizon to horizon, a luminous reminder of the vastness that surrounds our planet. What appears as a cloud is in truth a cross-section of the galactic disk, its light softened by distance and dust. Every point within that band represents thousands of stars, each contributing to the soft glow that humans have watched for millennia. The constancy of that view, unaltered across generations, reflects the enduring calm of the galaxy itself. Beneath its tranquil appearance, every component continues its slow transformation, governed by physical laws that never rest. Yet to the human eye it offers peace, a steady rhythm, against which time itself seems to slow. The Milky Way endures as both structure and sanctuary, a quiet spiral of matter and light drifting through the infinite dark, patient and timeless in its motion. From edge to center, the Milky Way operates like a vast ecosystem where every element contributes to balance and renewal. Stars form, evolve and die, returning their material to the interstellar medium in a continuous exchange that sustains the galaxy's life. In regions thick with gas, gravity gathers material into clouds many light-years wide. These clouds cool, condense and fragment into pockets dense enough to collapse into stars. Radiation from newly born suns shapes the surrounding gas, creating luminous regions where ionized hydrogen glows in shades of pink and red. Over millions of years, the heat and winds from these young stars push the gas outward, ending the formation cycle and leaving behind open clusters that slowly disperse into the galactic field. Older clusters drift apart as their stars wander along independent orbits spreading across the spiral arms. The Milky Way's structure ensures that this process repeats endlessly, with each generation seeding the next. In the thin disk, patterns of motion are guided by waves of density, much like ripples moving through water. These waves create the spiral shape familiar to observers, though no single arm is fixed. They are moving patterns of compression where gas is temporarily crowded, forming stars before the wave passes and the region returns to quiet. Between the arms, vast regions of space are sparse and dim, containing mostly older stars and diffuse dust. From a distance, the Milky Way would appear as a luminous whirlpool, bright along its arms and softly golden near its core. That central region, known as the bulge, contains some of the galaxy's oldest stars. It extends several thousand light-years above and below the galactic plane, merging gradually into the surrounding halo. The bulge is dense and dynamic, with stars orbiting in many directions, influenced by the gravitational pull of the supermassive black hole at the center. This black hole, Sagittarius A star, has a mass equivalent to millions of suns. It anchors the galaxy but remains largely quiescent, only occasionally flaring, as nearby gas falls inward and releases bursts of radiation. Around it, clusters of massive stars orbit at tremendous speeds, their paths curving through a region only a few light-years wide. Despite the energy there, the galaxy's heart remains stable on long timescales, pulsing gently with the slow rhythm of cosmic processes. Moving outward, the bar structure acts as a conveyor channeling gas from the inner regions toward the center and outward into the spiral arms. This flow maintains a balance between accumulation and dispersal, ensuring that the Milky Way does not stagnate. Along the arms regions, such as the Carina Nebula and the Cygnus complex, shine as vast laboratories of creation. Their filaments and cavities record the influence of radiation, wind and magnetism working together over millions of years. The gas and dust within them are composed largely of hydrogen and helium, but trace elements from older stars, carbon, nitrogen, silicon and iron, make the chemistry rich and varied. These materials are the ingredients of planets, moons, and in some cases life. Each time a massive star dies, it contributes a new supply of these elements, continuing the quiet enrichment of the galactic medium. The Milky Way's overall shape is slightly warped, its edges tilted upward on one side and downward on the other. This warp is thought to result from the gravitational influence of nearby satellite galaxies, or the uneven distribution of dark matter in the halo. The halo itself is enormous, extending far beyond the visible disk and containing most of the galaxy's total mass. Within it move globular clusters, dense spheres of ancient stars bound by gravity. These clusters orbit the Milky Way in long looping paths that take them far above and below the plane. Their stars are among the oldest known, dating back more than 10 billion years, and their chemical simplicity offers clues to the conditions of the early universe. Many of these clusters trace the remnants of past mergers when smaller galaxies were absorbed into the Milky Way. Evidence of such events can be seen in streams of stars that stretch across the halo remnants of systems long since dissolved. Each merger has added new material, subtly changing the galaxy's shape and enriching its diversity. This sun, one of hundreds of billions of stars in the Milky Way, resides within the Orion Arm, a minor spiral branch between the Sagittarius and Perseus arms. It orbits the galactic center at a steady pace, completing one revolution roughly every 230 million years. During that time, it oscillates gently above and below the galactic plane, a motion caused by the combined pull of all surrounding mass. The solar system moves through regions of varying density, sometimes passing near star-forming clouds, and at other times through sparse voids. These crossings occur so slowly that their effects are imperceptible within human history. Still, over geological timescales, they may influence the influx of cosmic rays and the conditions of interplanetary space. Beyond the disk, the Milky Way interacts continuously with the local group. The large and small Magellanic Clouds are its most visible companions, orbiting in elongated paths that generate streams of gas. These streams, stretching for hundreds of thousands of light years, eventually mix with the Milky Way's outer halo, providing fresh material for future star formation. Farther away, the Andromeda Galaxy approaches, slowly destined to merge with the Milky Way in several billion years. When that happens, the spiral patterns of both systems will distort and dissolve, giving rise to a new, more rounded galaxy. Despite the immensity of this transformation, the process will be gentle on individual stars whose vast separations prevent collisions. Their orbits will shift gradually, forming new patterns of equilibrium. Even as galaxies merge and evolve, the physical laws governing them remain constant. Gravity continues its steady work, shaping paths and cycles with quiet precision. Energy flows from hot young stars into surrounding space, while radiation from older ones fades into the background. The Milky Way's balance of these forces gives it stability that endures across epochs. Though immense and complex, the galaxy behaves like a single organism, its parts interconnected through light, motion, and time. Observations from space telescopes have deepened this understanding, revealing fine details once hidden by dust. Gaia's precise mapping of stars shows the disk to be rippled, suggesting that past interactions sent waves of motion through its structure. Each wave travels for millions of years, subtly altering stellar orbits. Yet the overall symmetry persists, a sign of the galaxy's resilience. Within this stability, delicate motions continue, clusters dissolve, nebulae, supernova remnants cool, and new stars ignite. The Milky Way's quiet persistence is a reflection of the cosmos itself, expansive, ordered, and serene. From the perspective of any single planet, it seems eternal. Its light crosses space and time, carrying the memory of creation in every photon. To gaze upon it is to witness continuity, a galaxy that has existed for almost as long as the universe, and that will remain long after its younger stars have cooled to embers. Within its unending rotation, the Milky Way drifts peacefully through the dark, its presence a constant, unhurried motion that defines the very rhythm of the night sky. The Milky Way story is written in light that travels across time, each photon a messenger from a different moment in its long history. Some of that light began its journey when early humans were learning to control fire. Some left its source before Earth itself formed. Every star contributes to this quiet chorus of illumination, blending into a soft radiance that arches across the sky. The combined glow outlines the thin galactic disk, a structure so vast that even at the speed of light, a beam would take 100,000 years to cross it. From within the galaxy appears flat and infinite, a landscape of stars stretching in all directions. Yet viewed from afar, it would resemble a luminous whirlpool set in the darkness, its spiral arms winding outward from a bright central bulge. The Milky Way's arms, Perseus, Sagittarius, Scutum Centaurus, and the Orion Spur, are not solid objects but moving patterns of density. Gas clouds slow as they enter these waves, compressing and sparking star formation before drifting onward. This movement keeps the arms glowing while their contents change constantly. Between them, vast spaces of thinner gas and older stars form the quieter regions of the disk. Across all of it, rotation is remarkably uniform. Stars near the edges move almost as swiftly as those near the center, a mystery that led to the discovery of dark matter. This unseen mass extends well beyond the visible boundaries shaping orbits and holding the galaxy together. Without it, centrifugal force would send the outer stars flying into intergalactic space. The halo of dark matter surrounds the Milky Way like an invisible shell encompassing both the disk and the swarm of faint distant satellites that orbit around it. Within this halo move the globular clusters, ancient spherical gatherings of stars bound tightly by gravity. Each cluster glows faintly, containing hundreds of thousands of old suns that have burned quietly for more than 10 billion years. They represent the first chapters of the galaxy's formation, relics from the time when the universe itself was young. Their paths through space trace the unseen contours of the Milky Way's mass, and by following their motion, astronomers can infer the distribution of dark matter. Between these ancient clusters, long streams of stars reveal remnants of smaller galaxies that have been absorbed over cosmic time. The Sagittarius stream, for instance, arcs across the sky as a record of one such merger. These traces show that the Milky Way is still growing, collecting matter from its surroundings in an endless process of assimilation. Every few billion years, another dwarf galaxy drifts too close and dissolves into the halo, its stars joining the larger population. In this way, the Milky Way has been shaped by both construction and consumption. At the center, the supermassive black hole continues its quiet governance. Though it occasionally flares when gas falls inward for most of its existence, it remains dormant, exerting control through gravity alone. Surrounding it are tight clusters of hot blue stars moving in orbits that complete within mere decades. Their rapid dance reveals the immense pull of the object they circle. Even at these speeds, the stars remain in balance, following precise paths determined by the combined mass of the core. Beyond this region, the density of stars lessens and the disk becomes dominant again, structured by vast waves of gas and dust. The Sun's place within this system is humble but secure, orbiting calmly among countless others. It lies about 27,000 light-years from the center, close enough to sense the galaxy's heart, yet distant enough to avoid its crowded intensity. Around the Sun, the Orion Spur extends as a minor branch linking larger arms. Here the stars are moderately spaced, the gas density balanced, and conditions stable enough for planetary systems to thrive. The solar system completes its orbit around the galactic center, roughly every 230 million years, a span so long that life on Earth has evolved dramatically between turns. Each revolution carries the Sun through regions of slightly different density, magnetic field and radiation, yet these variations occur so gradually that the experience on any single world is one of steady constancy. The Milky Way's light is not evenly distributed. Dust clouds block visible wavelengths, forming dark lanes that thread through the spiral arms. These clouds are made of fine particles, carbon ice, and silicates mixed with gas. They scatter and absorb light, cooling the regions behind them and allowing molecular hydrogen to form. Within these cool pockets, gravity takes hold and stars are born anew. Such clouds can stretch for hundreds of light years and contain material equal to millions of suns. Over time, stellar winds and radiation carve them into complex shapes, arches, bubbles, and pillars that slowly disperse. The remnants feed surrounding space with enriched elements, ensuring that each new generation of stars carries the legacy of those before. Throughout the galaxy, different regions tell different parts of this story. The inner arms are dense and active, where new stars emerge in brilliant clusters. The outer disk is thinner and more serene, its stars older and more widely spaced. Beyond even that lies the halo, a realm of solitude, where only ancient clusters and scattered stars drift in near silence. The transition from the inner to outer regions mirrors the passage of time itself, from youth and brightness toward calm and endurance. Yet even the faintest areas of the Milky Way are alive with motion. Gas flows inward and outward, magnetic fields twist and reconnect, and cosmic rays stream through invisible paths. These processes keep the galaxy dynamic, preventing it from ever becoming static. Over billions of years, gravitational interactions with neighboring galaxies have nudged and warped its shape. The most significant influence comes from the approaching Andromeda galaxy, which moves toward the Milky Way at several hundred kilometers per second. In about 4 billion years, the two spirals will meet and merge, their stars mingling in slow gravitational choreography. Such a collision will reshape the night sky but not destroy it. The combined galaxy will settle into a new form, its starlight smoother and rounder, its core brighter. This distant future echoes the long continuity of the Milky Way's existence. From its earliest days, it has absorbed smaller companions, grown through accretion, and maintained equilibrium across unimaginable timescales. To view it from within is to glimpse both change and permanence, the slow pulse of creation, sustained by universal laws. The galaxy's rotation, its waves of star formation, and its exchanges with the cosmos all proceed without haste. Every part of it, from the faint outer halo to the radiant center, moves according to patterns set in motion billions of years ago. The Milky Way is in essence a calm whirlpool of energy and matter, its grandeur arising not from violence, but from the enduring order of its design. Light, gravity, and time interlace here into one of the universe's most enduring structures. Across its breadth, stars burn, fade, and renew, while the galaxy itself continues its serene drift through space, unchanged in spirit, even as its details evolve. For as long as the universe allows, the Milky Way will remain a slow-spinning beacon of stability, a cosmic home where everything from atoms to worlds follows the same gentle rhythm of creation and return. The Milky Way continues to evolve quietly, shaped by processes so slow and steady that from the perspective of human history it appears eternal. Stars are born, live, and die across spans of time so vast that even the galaxy's most dynamic events unfold with serenity. At any given moment, thousands of stars are forming within the great molecular clouds that lie along the spiral arms. These regions, dark in visible light, shine softly in infrared as gravity draws together cold hydrogen and dust. Within each cloud, small knots collapse into protostars, their centers heating until nuclear fusion begins. The surrounding material flattens into rotating disks that will eventually form planets, moons, and smaller debris. The pattern repeats endlessly, ensuring that the Milky Way remains luminous even as its oldest stars fade. When massive stars reach the end of their short lives, they explode as supernovae, sending waves of gas into surrounding space. These shock fronts compress nearby clouds, triggering yet more star formation. The energy released in each explosion also forges heavier elements, iron, nickel, and gold, that mix into the galactic medium. In this way, the chemical composition of the Milky Way grows richer over time. The dust and gas that once belonged to older generations of stars now provide the material for new ones. Smaller stars end more quietly, shedding their outer layers into glowing shells known as planetary nebulae. Their cores shrink into white dwarfs that will cool over billions of years, eventually becoming dark remnants. Scattered across the galaxy, these remnants drift silently, reminders of an earlier era. The combined light of all stars, past and present, forms the diffuse glow that gives the Milky Way its name. From Earth, that glow appears as a pale band because we view it from within the disk, looking through a crowded plane of countless suns. Beyond visible light, the galaxy radiates in many wavelengths. Radio waves from cold hydrogen, infrared from dust, and X-rays from energetic regions near black holes and neutron stars. Each wavelength reveals a different layer of its structure, and together they form a portrait of harmony and complexity. The Milky Way's magnetic fields wind through this environment like unseen threads. They guide the motion of charged particles and help shape the filaments of gas seen in radio maps. Though weak compared to gravity, these fields influence the alignment of dust grains and affect how light is polarized as it travels through space. They also play a role in the formation of stars by directing how gas collapses within clouds. Over large scales, the magnetic pattern follows the spiral arms, weaving a subtle order through apparent randomness. Closer to the galactic center, conditions intensify. The region surrounding Sagittarius, a star, contains stars packed so densely that their average separation is only a fraction of a light year. Infrared observations reveal orbits that move swiftly and precisely, confirming the presence of the central black hole. Occasionally, a cloud of gas strays too near and spirals inward, heating to millions of degrees and releasing brief flares of X-rays. Most of the time, however, the black hole remains quiet, a gravitational anchor rather than a destructive force. Around it, ancient stars continue their slow motion, maintaining the equilibrium of the bulge. This central region extends several thousand light-years and connects smoothly with the bar that channels gas inward. The bar, rotating slowly, is a bridge between the inner and outer galaxy, ensuring a steady circulation of material. Beyond it, the spiral arms unfurl, rich with star-forming regions and open clusters. Some clusters stay bound for hundreds of millions of years, while others disperse quickly, their stars joining the wider population of the disk. These stars move in coordinated orbits around the galactic center, maintaining a near-constant rotational velocity despite differences in distance. This uniformity, first noticed by astronomers in the 20th century, provided the earliest evidence of dark matter. The unseen halo surrounding the Milky Way contains the majority of its mass, holding the outer stars in place and defining the limits of the galaxy's influence. The halo itself is faint, filled with old stars and globular clusters that orbit on elongated paths. Many of these clusters are relics of smaller galaxies absorbed long ago, their stars now blending seamlessly into the Milky Way's population. The halo also contains streams of stellar debris, thin ribbons that trace the remnants of past mergers. These structures show that the galaxy is still accreting material, its growth continuing even in the present era. Beyond the halo lies intergalactic space, a realm of tenuous gas and invisible matter that connects the Milky Way to its companions. The large and small Magellanic Clouds orbit within this region, trailing vast streams of hydrogen that wrap around the galaxy. Over time, these streams will spiral inward and merge, fueling future star formation. Other dwarf galaxies too faint to see with the naked eye orbit within the halo, each adding subtle distortions to the Milky Way's shape. Their gravitational influence helps maintain the warp observed in the outer disk. From above, the galaxy would appear slightly twisted, its edges tilted in response to these interactions. Yet the overall symmetry endures a sign of its resilience through cosmic encounters. The Milky Way's journey through the universe is equally tranquil. It moves as part of the local group, a collection of about 50 galaxies bound together by mutual gravity. The most massive members, the Milky Way and Andromeda, draw gradually toward one another and will eventually merge in several billion years. The approach is slow and graceful, unfolding far too gradually for human senses to perceive. When the two galaxies finally meet, their stars will pass mostly unharmed, though their orbits will shift as the combined system settles into a new shape. The result will be a large elliptical galaxy glowing softly at the heart of a still larger structure. Such mergers are part of the natural evolution of the cosmos, where growth and transformation proceed without haste. Even now, faint tidal bridges of stars and gas link the Milky Way with its companions, reminders that connection is intrinsic to galactic life. Closer to home, the solar system continues its patient orbit, moving through gentle gradients of dust and radiation. Every few tens of millions of years it passes through one of the galaxy's spiral arms, encountering slightly denser environments that may influence the influx of comets and cosmic rays. These passages, though imperceptible to life on Earth, form part of the grand rhythm of the galaxy. All around, invisible particles and waves travel through space, exchanging energy in ways that maintain overall stability. The Milky Way's rotation, its internal flows and its exchanges with the universe at large create a pattern that is both dynamic and calm. From its luminous core to its faint halo, every layer operates in harmony with the others. It is a system of balance where gravity, light, and time collaborate to produce quiet order. For billions of years this balance has endured, and for billions more it will continue. Long after the sun fades, the galaxy will still turn serene and complete, its light spreading across the darkness like a slow, eternal breath. The Milky Way's existence stretches back almost to the beginning of time, its origins rooted in the faint irregularities that emerged after the universe cooled from its earliest moments. Tiny clumps of matter slowly grew through gravity, merging and gathering gas until the first small galaxies formed. Out of these ancient fragments, the Milky Way began to take shape more than 13 billion years ago. In those early epochs, the galaxy was chaotic, filled with massive short-lived stars that burned intensely and died in violent supernovae. Each explosion enriched the surrounding gas with heavier elements, allowing new generations of stars to form with increasing complexity. Over time, the merging of many smaller galaxies produced a single larger system, whose center condensed into what would become the Milky Way's bulge. As the galaxy matured, a flat rotating disk developed around this bulge, giving rise to the spiral structure that defines it today. The earliest stars of the Milky Way still exist hidden in the halo, and globular clusters, their light faint but steady. These stars are relics of an age before the galaxy settled into order. Their simplicity in chemical composition reveals the purity of the early universe, when only hydrogen and helium were abundant. Gradually, as supernovae seeded space with new elements, the conditions for planets and life were set into motion. In the young Milky Way, collisions between clouds of gas shape the formation of spiral arms. These arms are sustained by waves of density that move through the disk, compressing material and setting off chains of starbirth. This process continues today, ensuring that even after billions of years the Milky Way remains vibrant. Star-forming regions glow across the galaxy, especially in the inner arms where gas is densest. The light of newborn stars illuminates the dust, revealing complex structures of filaments and cavities carved by radiation and stellar winds. Massive stars dominate these regions for a short while, but their influence endures long after they fade. Their supernova remnants enrich the galactic medium, forming the foundation for new systems. In this way, the Milky Way constantly recycles itself, turning old material into new light. The galaxy's spiral pattern is not fixed, but slowly changes, guided by gravity and time. Each rotation of the disk takes hundreds of millions of years, yet over cosmic history, these slow revolutions have smoothed irregularities and stabilized the structure. Still, the Milky Way is not isolated. It lives within a cosmic neighborhood sharing space with Andromeda, the Triangulum Galaxy, and dozens of smaller satellites. The gravitational pull between them creates subtle distortions in each system. Streams of stars in the outer halo testify to these interactions, remnants of galaxies long ago drawn into the Milky Way's orbit and stretched apart. Their stars now move as faint ribbons across the sky, merging seamlessly with the main body. The halo extends far beyond the visible disk, containing ancient stars and a vast envelope of dark matter. Though invisible, this dark matter makes up most of the galaxy's mass and governs its motion. The Milky Way's outer stars travel faster than they should. If only visible matter were present, evidence of this unseen structure that envelops the galaxy like a gentle gravitational cocoon. Within the visible disk, the Sun and its planets occupy a quiet region known as the Orion Arm. Here conditions are relatively stable, with moderate star formation and sparse dust clouds. The Sun's orbit around the galactic center is nearly circular, maintaining a comfortable distance of about 27,000 light-years from the core. This position keeps the solar system well away from the crowded inner regions where radiation and gravitational turbulence are higher. The Sun completes one orbit roughly every 230 million years, a period often called a galactic year. During each orbit, the solar system also oscillates up and down through the galactic plane, crossing it every few tens of millions of years. These movements carry it through patches of varying density and radiation, shaping the environment through which cosmic rays and interstellar particles flow. Yet the pace is so slow that life on Earth experiences only stillness. The Milky Way's long-term stability arises from its immense scale and self-regulating dynamics. Gas clouds collapse to form stars, but stellar winds and supernovae return material to space, preventing runaway growth. Gravitational forces keep the system balanced while radiation gradually disperses excess energy. Over billions of years, this balance has allowed the Milky Way to remain ordered amid constant change. Even the warping of its disk, likely caused by gravitational interactions with the Magellanic Clouds or the dark matter halo, evolves so slowly that it poses no threat to the galaxy's symmetry. Instead, it adds a gentle curvature to the outer edge, a subtle reminder that no structure in the universe is perfectly rigid. The Milky Way's magnetic field threads through all of this with quiet persistence. It aligns dust grains, channels charged particles, and shapes the flow of gas. Observations reveal that the field follows the spiral pattern of the galaxy, looping outward along the arms and curving back through the interstellar medium. Though weak, it contributes to the galaxy's coherence, guiding the subtle interplay between matter and radiation. In the center, beneath layers of obscuring dust, lies Sagittarius A, a supermassive black hole millions of times heavier than the Sun. Stars near it orbit at extraordinary speeds, revealing its gravitational strength. Occasionally, a passing cloud of gas spirals inward, releasing bursts of X-rays as it disappears beyond the event horizon. For the most part, however, the black hole rests in silence, anchoring the Milky Way like a weightless core. Around it, the bulge glows with the light of ancient stars that have endured for most of cosmic history. This region is thick with motion stars crossing paths in dense orbits, some thousands of light years above or below the plane. Yet despite this complexity, the overall effect is one of equilibrium. Every orbit, every flow of gas, every flicker of light participates in a vast and harmonious motion. Beyond the visible disk, high-velocity clouds drift through the halo, feeding the galaxy with new material. Some are remnants of small galaxies torn apart by gravity. Others may be streams of gas drawn from intergalactic space. These clouds ensure that the Milky Way will continue forming stars for billions of years to come. Even as its overall rate of star formation slows, the process never truly ends. New light continues to emerge, faint but constant, preserving the galaxy's glow. In the far future, when Andromeda approaches and the two galaxies merge, their combined structure will change shape but not essence. The spiral arms will stretch and fold, and their stars will mix into a single vast elliptical galaxy. Yet to any observer living within it, the change will unfold with imperceptible calm. The light of billions of suns will still shine, the rhythm of orbits will continue, and the memory of the Milky Way will persist within that new form. From its beginnings in the young universe to its future transformation, the Milky Way endures as a symbol of continuity, a cosmic spiral of matter and light sustained by balance and time. Its slow rotation, the faint hum of radiation, and the unending formation of stars together compose a music so vast that it defines the very concept of stability in a changing cosmos. The Milky Way is not a static monument in space, but a living system that breathes across billions of years, quietly shaped by gravity and motion. Its spiral arms filled with gas and stars drift slowly through a sea of interstellar dust, maintaining patterns of light and darkness that appear unchanging from human eyes. Each star, each grain of dust participates in an intricate balance of forces that keeps the galaxy whole. From its luminous center to its faint outer halo, the Milky Way holds together through the steady pull of gravity, acting in perfect equilibrium with motion. The Sun and its planets move along a nearly circular orbit through one of the smaller arms surrounded by stars of similar age and brightness. Every second the solar system travels thousands of kilometers through space, yet to an observer on Earth, the galaxy's grand rotation remains invisible. The timescale of its movement is too immense for human perception. Over hundreds of millions of years, however, the Sun traces a vast circle around the galactic center, weaving gently above and below the plane, in a rhythm that repeats through deep time. During these oscillations, the solar system passes through different regions of dust and gas, occasionally near clusters or nebulae, before emerging again into calmer space. The galaxy's structure allows such motions to remain stable, preserving the overall pattern, even as individual stars drift and shift. Gravity binds every element together, ensuring that the Milky Way maintains its symmetry across epochs. Its spiral form is not a rigid framework, but a wave of density that moves through the disk, compressing gas and giving rise to new generations of stars. The arms exist because matter crowds temporarily in certain regions before continuing onward, leaving behind clusters and nebulae that gradually disperse. This gentle cycling creates the impression of permanence even though every atom is in motion. Star-forming regions like the Eagle Nebula and the Lagoon Nebula illustrate the quiet vitality of this process. Within their glowing clouds, the faint warmth of starlight balances the cold pull of gravity shaping the birthplaces of suns. Over time, radiation from young stars erodes the gas around them, revealing newborn clusters against the darkness. The Milky Way contains thousands of such regions, each at a different stage in the endless cycle of creation and dispersal. The stars themselves follow well-defined paths of evolution. Massive ones live briefly, shining fiercely in blue light, before collapsing in supernovae that enrich the galaxy with heavy elements. Smaller stars like the Sun burn slowly and steadily for billions of years, ending as faint white dwarfs. The remnants of all these lives fill the interstellar medium with dust and gas, forming the raw ingredients for future systems. Nothing in the galaxy is wasted. Everything returns to the cycle. The combined light of its billions of stars forms the pale ribbon that arcs across Earth's night sky. To the unaided eye, it appears as a smooth band, but telescopes reveal immense complexity, lanes of dark dust, knots of nebulae, and clusters that gleam like grains of salt scattered across velvet. The light that reaches Earth from the far side of the galaxy left its source tens of thousands of years ago, so each view of the Milky Way is a glimpse of history. In this way, the night sky preserves a silent record of cosmic time, its beauty born of distance and delay. The galactic core, hidden behind thick clouds of dust, radiates in infrared and radio light, revealing its crowded interior. Thousands of stars orbit the central black hole Sagittarius A, which anchors the Milky Way with its immense gravity. Though invisible, its presence defines the motion of nearby stars, holding them in orbits that trace elegant ellipses around the unseen mass. Occasionally, as a stream of gas falls inward, the black hole brightens briefly, emitting flares that travel across the spectrum before fading again. These outbursts are brief on galactic timescales and do little to disturb the overall calm. The core itself is old, composed largely of stars formed when the Milky Way was young. Their light is reddish and steady, contributing to the warm glow that dominates the inner bulge. The central bar, a structure of stars and gas that extends outward from the bulge, rotates slowly, channeling material into the arms and maintaining the galaxy's spiral shape. This process keeps the Milky Way balanced, ensuring that matter circulates from the outer disk inward and back again in a continual exchange. Surrounding the disk is the halo, a vast, nearly spherical region containing ancient stars and globular clusters. These clusters orbit at great distances, some completing a single circuit in hundreds of millions of years. They are the fossils of the early galaxy, their compositions revealing how the Milky Way accumulated its mass from smaller systems. Streams of stars, remnants of past mergers, arc across the halo, mapping invisible currents of dark matter. This dark matter, though unseen, outweighs all visible material in the galaxy and provides the gravitational framework that holds everything together. Without it, the outer stars would fly apart, but instead they remain bound in a graceful rotation that has lasted for billions of years. The Milky Way's interactions with neighbouring galaxies continue to shape its evolution. The large and small Magellanic Clouds orbit nearby their gas, forming long filaments that wrap around the outer halo. These filaments feed the galaxy, replenishing its star-forming material. Over time, gravitational tides will draw the Magellanic Clouds inward, and they too will merge with the Milky Way, adding to its mass and changing its structure only subtly. The most distant and dramatic future event will be the meeting with the Andromeda Galaxy, now moving slowly toward collision. This encounter, though vast, will unfold gently, taking billions of years to complete. The stars of both galaxies will pass mostly unharmed their orbits, combining into new configurations that form an immense elliptical system. Even after this transformation, the essence of the Milky Way will remain the same stars, the same cycles, only rearranged within a new shape. On smaller scales, life within the galaxy continues its quiet rhythm. Pulsars spin in the aftermath of supernovae, their beams sweeping across space like distant metronomes. Neutron stars and black holes drift silently through the disk remnants of massive suns long gone. Between the stars, cold clouds of gas condense and disperse, guided by the galaxy's magnetic field. Cosmic rays traveling near the speed of light weave through these regions, transferring energy across vast distances. All these elements, stars, remnants, dust, and radiation, form an interconnected system that functions in harmony. To human eyes, this harmony translates into beauty and calm. The Milky Way is both an object and a process, both ancient and alive. Its patterns remain steady while its contents flow and change. Each night when its faint band appears overhead, it offers a glimpse into this grand continuity, a system of light, gravity, and time that endures beyond measure. Every star adds to the quiet order that defines the galaxy, and every atom participates in its motion. The Milky Way turns unhurriedly, keeping its shape across eons, carrying within it the history of the universe and the promise of its future. The Milky Way viewed as a whole is a calm spiral of light suspended in darkness, but within that stillness countless motions intertwine. Each star follows its own path through the galaxy, yet the collective movement appears ordered, as though every orbit obeys a quiet rhythm. The disk rotates once every few 100 million years, and this slow revolution governs all structure within it. From its luminous core to its faint edges, the Milky Way behaves like a single vast organism, self-regulating and enduring. The stars closer to the center orbit faster, while those farther out maintain similar velocities due to the unseen mass of dark matter that surrounds everything. This invisible halo extends for hundreds of thousands of light years, shaping the gravitational landscape that keeps the galaxy whole. Without dark matter, the outer stars would drift away into space, but instead they remain bound, circling endlessly around the center. The Milky Way's shape, a barred spiral, is defined by its delicate balance between gravity and motion. The central bar stretches across thousands of light years, channeling gas toward the middle and feeding regions of star formation. The spiral arms emerge from its ends like rivers of light curving outward in a graceful sweep. These arms are not fixed structures but density waves that move through the disk, compressing gas and dust as they pass. Within them stars are born from molecular clouds, and as the wave continues onward, the newborn stars remain behind, slowly aging and drifting into quieter orbits. This constant renewal gives the galaxy its subtle glow. The light that reaches Earth on any given night represents the collective radiance of hundreds of billions of stars, most too faint or distant to distinguish individually. The band of the Milky Way visible across the night sky is an edge-on view of its disk, revealing the dense midplane where stars, gas and dust are most concentrated. Through binoculars or a telescope, that soft band resolves into countless points of light, each one a world unto itself. The Milky Way's central region, though hidden behind clouds of interstellar dust, radiates strongly in infrared and radio wavelengths. Here lies Sagittarius A, the supermassive black hole, whose mass equals millions of suns. Stars orbit it in tight, rapid ellipses, some completing a circuit in just a few decades. Their motions trace the invisible gravity of the black hole, confirming its presence, even though it cannot be seen directly. Occasionally streams of gas fall inward, heating and emitting bursts of X-rays, before disappearing beyond the event horizon. Yet these episodes are rare, and for most of the time the center remains tranquil, Around it, dense clusters of old stars crowd the bulge, creating a golden haze that glows through the obscuring dust. The bar structure connecting this bulge to the spiral arms acts as a bridge, transferring matter and energy through the galaxy's inner regions. Farther out, the disk flattens into a thin layer just a few thousand light-years thick. Here, star formation occurs in enormous complexes of gas known as giant molecular clouds. Within these clouds, gravity slowly pulls material together until fusion ignites, marking the birth of new suns. The Orion Nebula, though small compared with the great factories deeper in the arms, offers a nearby example of this quiet process. Across the galaxy, similar regions come and go, shaping the light that defines its form. The stars born in these nurseries gradually disperse their collective orbits, giving the arms their persistent brightness. Some live for only a few million years before ending as supernova, scattering heavy elements into space. Others, smaller and steadier, endure for billions of years, maintaining the galaxy's long-term glow. Every explosion, every burst of radiation contributes to the circulation of material. The dust that obscures light from the Milky Way's center is composed of elements created in ancient stars' carbon, silicon, oxygen, and iron. These atoms form solid grains that drift through the interstellar medium, gathering in cool clouds and reflecting starlight in subtle hues. Though thinly spread, this dust defines much of the galaxy's character, absorbing and re-emitting light in complex patterns. It shapes the view of the Milky Way seen from Earth, creating the mottled texture across its glowing band. Within the dust, new stars and planets take shape, continuing the cycle of creation that has persisted since the galaxy's formation. Beyond the disk lies the halo, an almost spherical volume that extends far into intergalactic space. The halo is populated by old stars' globular clusters and immense reservoirs of dark matter. Many of these clusters are older than 10 billion years, their stars formed before the Milky Way assumed its current structure. They orbit the galactic center in elongated paths, often far above or below the plane of the disk. Their light is faint and steady, a reminder of the galaxy's early youth. In addition to these clusters, the halo contains streams of stars, the remains of smaller galaxies absorbed by the Milky Way. Each stream traces a former orbit, wrapping around the galaxy like a ghostly thread. Observations of these streams allow astronomers to map the distribution of dark matter, revealing that the Milky Way's invisible mass extends much farther than its luminous body. The galaxy's edges are not sharply defined, but blend gradually into intergalactic space, where faint gas and cosmic radiation fill the void. The Milky Way belongs to a small collection of galaxies known as the Local Group. Its nearest large companion, the Andromeda Galaxy, lies more than 2 million light-years away and approaches slowly under the pull of gravity. In several billion years, the two galaxies will merge, forming a single larger system. Despite the scale of this collision, it will unfold peacefully, as the immense distances between stars mean that direct impact will be rare. Instead, the galaxies will pass through one another, their stars redistributed into a new rounded shape. The Milky Way will survive within this transformation, its material reconfigured, but its essence unchanged. The galaxy's calm evolution continues even now. Streams of gas from the Magellanic Clouds feed its outer halo, replenishing the supply of star-forming material. Gravitational interactions with nearby satellites generate subtle ripples that move through the disk like slow tides. These waves take hundreds of millions of years to cross the galaxy, creating gentle oscillations that alter the thickness and warp of the outer regions. Meanwhile, inside the disk, magnetic fields thread through clouds of gas, guiding their collapse and influencing how stars form. Cosmic rays travel along these magnetic pathways, carrying energy, across vast distances and contributing to the delicate equilibrium of heat and motion. In this balance, nothing is wasted and nothing is hurried. The Milky Way endures by renewing itself in every corner, stars forming from dust, dust forming from stars, energy cycling between light and matter. From the perspective of any single world, this process feels eternal, yet it is merely one part of an even longer cosmic story. The Milky Way is both a memory of the past and a promise of the future, its quiet light spanning time itself. It drifts through the universe as a vast self-sustaining structure, serene, ancient and alive, turning forever in the dark, carrying with it every spark of light that has ever existed within its reach. The Milky Way drifts through the universe as a calm spiral of light bound by gravity, yet appearing weightless in the vast dark. Its motion is steady, measured in cycles that last hundreds of millions of years. Every star, cloud and cluster follows a path within this rotation, creating a harmony of movement too slow for human eyes, but precise across cosmic time. The galaxy's arms, softly glowing with the light of countless suns, mark the regions where stars are born. Within these arms, waves of density pass through the gas, compressing it, and triggering star formation before continuing onward. The arms themselves move more slowly than the stars they contain, allowing material to flow in and out as it orbits the center. This continuous motion sustains the spiral pattern, a self-perpetuating design that has endured for billions of years. The Milky Way's overall balance depends on gravity, dark matter, and angular momentum. Dark matter, unseen but pervasive, extends far beyond the visible disk, its gravity shaping the orbits of stars in the outer regions. Without it, the galaxy would unravel its components, scattering into the void. Instead, the invisible halo provides stability, ensuring that rotation remains smooth and constant. The disk, a thin layer of stars and gas only a few thousand light-years thick, stretches outward to distances that defy imagination. It is within this disk that nearly all visible features of the Milky Way reside: the spiral arms, the clusters, the nebulae, and the faint clouds of dust that absorb and scatter starlight. From Earth, this combination appears as a band across the night sky, a river of light flowing from horizon to horizon. Each point within that band represents not a single star, but millions, their combined glow softened by distance and dust. The galaxy's color changes subtly from the bright yellow of its center to the cooler blue of its outer arms, reflecting the distribution of older and younger stars. The central bulge glows with ancient light, its population dominated by red and yellow stars that have burned steadily since the early days of the galaxy. In this region, stars orbit in crowded and complex paths around the gravitational anchor of Sagittarius A, the supermassive black hole. Though invisible, the black hole reveals itself through the motion of nearby stars, which race around it in orbits that complete within decades. Occasionally a stray cloud of gas or dust falls inward, heating to extreme temperatures and emitting bursts of X-rays. For most of its life, however, the black hole remains silent, influencing the galaxy only through its immense gravity. Surrounding the bulge, the bar structure acts as a dynamic bridge, transferring gas inward toward the core and outward into the spiral arms. This slow flow keeps the Milky Way alive with new material fueling regions of star formation. Beyond the bar, the spiral pattern continues, divided into several main arms and smaller spurs. The Perseus arm, the Sagittarius arm, and the Scutum Centaurus arm curve outward in long arcs, while the Orion spur, home to the Sun, connects them like a smaller thread. These arms are vast regions of light and shadow, filled with clusters, nebula, and diffuse dust clouds. Within them, enormous molecular complexes span hundreds of light years, serving as cradles for new stars. When massive stars form, their radiation illuminates the surrounding gas, creating glowing nebulae that shine for a few million years before fading. Supernova explosions at the end of these stars' lives spread heavy elements into space, enriching the gas and dust that will later form planets. The Milky Way's chemical evolution is a slow accumulation of such contributions. Each generation of stars leaves behind material richer in carbon, oxygen, and iron than the last. Over billions of years, this enrichment has created the diversity of elements found throughout the galaxy. The Sun and its planets are products of this long process, born from clouds that had already been seeded by countless earlier stars. Around the Sun, the solar system moves through the galaxy at a speed of over 200 kilometers per second, completing one orbit every 230 million years. This journey carries it through regions of differing density and radiation, though the changes unfold so gradually that no trace of motion is felt on Earth. The Sun's path is stable, oscillating gently above and below the galactic plane as it follows the curvature of the Orion Spur. From this vantage point, the Milky Way's grandeur is seen from within its vastness, hinted at by the dense field of stars visible on clear nights. The galaxy's disk is not perfectly flat. Its outer edges bend upward and downward in a slow, graceful warp. This distortion is likely caused by gravitational interactions with nearby satellite galaxies such as the Large and Small Magellanic Clouds, whose orbits exert subtle tugs over billions of years. These small galaxies orbit within the Milky Way's extended halo, leaving trails of gas known as the Magellanic Stream. These streams, stretching for hundreds of thousands of light-years, feed the Milky Way with new material, ensuring that star formation continues. Other dwarf galaxies, some so faint they are barely detectable, follow similar paths around the halo. Over time, many of them will merge completely with the Milky Way, their stars dissolving into its population. Evidence of past mergers exists in the form of stellar streams, long ribbons of stars winding through the halo, each one a remnant of a galaxy absorbed long ago. The halo itself is a quiet region, sparse and ancient, filled with globular clusters, whose stars have remained unchanged for 10 billion years or more. These clusters orbit far from the disk, moving through space in elongated paths that cross the galaxy's outer boundary. Their light is faint but steady, the glow of old suns that have endured since the Milky Way's earliest days. The galaxy's mass is distributed unevenly, with most concentrated in the center, and the thin disk, while the halo contributes the invisible balance needed for stability. Together, these layers bulge, bar disk and halo form a coherent system that functions without interruption. Beyond the Milky Way's limits, the surrounding universe stretches outward in every direction. The galaxy belongs to the local group, a cluster of about 50 galaxies bound together by gravity. The largest among them are the Milky Way and Andromeda, which approach each other slowly. In several billion years, they will merge their shapes, blending into a new, larger galaxy. The event will unfold so gradually that no single observer could ever notice its progress. Stars will pass unharmed, and new orbits will form as gravity reshapes the system. The memory of the Milky Way will live on within this future galaxy, its stars continuing to shine in new patterns. Until then, the Milky Way continues its patient rotation, renewing itself in cycles of creation and decay. Its stars pulse, its clouds shift, and its arms wind through space with quiet elegance. From the perspective of time measured in billions of years, it is almost still a stable structure within a restless cosmos. Yet even in stillness, it changes, adapting to the invisible forces that act upon it. The Milky Way's calm light is the sum of all those transformations, each one contributing to the beauty seen from Earth's night sky. It endures as a living record of cosmic balance, vast yet gentle, forever turning in the silent expanse of space. The Milky Way is a structure of extraordinary scale, yet its movements are so smooth that its vastness feels motionless. It is a barred spiral galaxy composed of billions of stars, a disk of luminous matter, surrounded by an even larger halo of invisible dark matter. From its bright core to its faint perimeter, the galaxy operates as a single balanced system where every motion serves a purpose. The gravitational influence of dark matter holds the galaxy together, countering the centrifugal forces of rotation. Without this unseen mass, the Milky Way's stars would scatter into the darkness, but instead they remain bound in a slow, majestic orbit around the centre. The Sun and its planetary system are small participants in this cosmic dance, moving at great speed yet confined within the serenity of the galactic order. Each orbit takes about 230 million years, a span that dwarfs the entirety of human civilization. During that time, the solar system drifts through different regions of the Orion Arm, occasionally passing near bright clusters or diffuse clouds of interstellar gas. These encounters are so gradual that from Earth's perspective the night sky remains constant. The same constellations that guided ancient travellers will persist for millennia, though beneath that apparent permanence every star is in motion. The Milky Way's structure reveals the balance of creation and decay that defines its life. In the spiral arms, vast molecular clouds give birth to stars. These regions are cold and dense, where hydrogen atoms bind into molecules and gravity draws material inward. Over millions of years, pressure builds until fusion ignites and a new star begins to shine. The surrounding dust and gas are illuminated, forming nebulae that glow in soft hues of pink, blue and gold. The largest and hottest stars live short lives, burning brightly before collapsing in violent supernovae. These explosions scatter heavy elements into space iron, carbon, oxygen, and silicon, the building blocks of planets and ultimately life. Smaller stars endure quietly for billions of years, their slow burn maintaining the galaxy's steady light. Every stage of a star's life contributes to the Milky Way's evolution. The gas expelled by dying stars becomes the material for new ones, ensuring that nothing is lost. This continuous recycling of matter sustains the galaxy's glow across the ages. The central bulge of the Milky Way, spherical and dense, contains some of its oldest stars. Many are more than 10 billion years old survivors from the galaxy's earliest epochs. These stars orbit within the gravitational field of Sagittarius A, the supermassive black hole at the centre. Though the black hole itself emits no light, its influence is evident in the rapid orbits of nearby stars, some moving at thousands of kilometers per second. Occasionally a passing cloud of gas is drawn inward, heating to millions of degrees and producing brief flares of X-rays before disappearing. Despite its immense power, the black hole remains stable, a silent anchor for the galactic core. The bulge connects to the central bar, a long structure of stars and gas that rotates slowly, linking the inner regions to the spiral arms. The bar acts as a channel through which matter flows, feeding the core and driving star formation along its edges. Beyond it, the spiral arms curve outward, their graceful shapes traced by the light of young stars. Each arm is a lane of activity where gravity, pressure and radiation work in harmony. Between them lie quieter regions, sparsely populated and dominated by older stars that have drifted from their birthplaces. The Milky Way's overall appearance is that of a flat glowing disk with subtle ripples near its edge. These ripples or warps are caused by gravitational interactions with the Magellanic Clouds and other satellite galaxies. The Milky Way's outer disk bends gently upward on one side and downward on the other, creating a slow, wave-like motion that travels through the gas and stars. Such deformations are reminders that the galaxy is not isolated but part of a larger system. Around it orbit dozens of smaller galaxies, some bright enough to be visible to the naked eye. The large and small Magellanic Clouds are the most prominent, irregular in shape and rich in gas. They are connected to the Milky Way by long streams of hydrogen that feed new star formation. Other dwarf galaxies, faint and diffuse, trace elongated paths through the halo. Over billions of years, many of them will merge completely their stars, becoming part of the Milky Way's outer regions. The remnants of past mergers can still be seen in the form of stellar streams, delicate filaments of stars that wrap around the galaxy. These remnants tell the story of how the Milky Way grew, gradually consuming smaller systems to reach its present size. The halo that envelops the galaxy is vast and ancient. It contains old stars, globular clusters, and the bulk of the Milky Way's dark matter. Globular clusters are spherical gatherings of hundreds of thousands of stars, each orbiting tightly bound around their common center. They are among the oldest structures in the galaxy, dating back to its earliest formation. Their orbits carry them far above and below the galactic plane, taking hundreds of millions of years to complete. Within their dense cores, stars are packed closely together, glowing softly against the darkness. These clusters, along with the diffuse halo, form a kind of outer memory, preserving the Milky Way's history in their slow motion. The galaxy's mass is so great that it bends the motion of nearby companions, and even affects the flow of intergalactic gas. It drifts within the local group, accompanied by Andromeda and the Triangulum Galaxy, along with many smaller satellites. The gravitational attraction between the Milky Way and Andromeda ensures that one day, billions of years from now, they will merge. This future event will not be catastrophic but transformative, unfolding gradually as their stars pass safely through one another. The two galaxies will combine into a larger elliptical system, and the memory of the Milky Way's spiral arms will live on in the arrangement of its stars. Until that distant moment, the Milky Way remains stable and luminous, a place of quiet activity and enduring calm. It continues to generate new stars at a modest rate, balancing creation with loss. Its magnetic fields weave through the gas, guiding charged particles and shaping the delicate structure of interstellar clouds. Cosmic rays flow outward, interacting with dust and plasma, spreading energy across vast distances. Every element of the galaxy contributes to this equilibrium. From the perspective of human time, the Milky Way is timeless, a constant presence in the night sky, unchanged and serene. Yet within its stillness lies continuous motion, stars, drifting gas, flowing light, travelling across unimaginable distances. It is both ancient and alive, its beauty defined not by chaos but by order. The Milky Way endures as a beacon of cosmic balance, a slow, turning system of light and gravity that move with quiet precision through the dark sea of the universe. The Milky Way moves through the universe as a grand spiral of order, its form maintained by the interplay of gravity, rotation, and time. Though it appears static from the human vantage point, every component within it follows a precise motion, dictated by the mass and structure of the galaxy. Each star cluster and cloud contributes to the stability of the whole. From its luminous center to its outer halo, the Milky Way operates as a system of balance where energy and matter flow in endless cycles. The disk where most of the galaxy's visible light originates is a vast thin layer, only a few thousand light-years thick, but over 100,000 light-years across. Within it, stars orbit in nearly circular paths, moving through spiral arms that trace the slow wave of density shaping the galactic pattern. These arms are regions of higher concentration, where gas clouds compress and ignite into new stars. Between them lie calmer expanses of older stars' faint dust and diffuse gas. The disk rotates once every few 100 million years, yet its appearance remains remarkably stable. The combined light of billions of stars forms a soft continuum that stretches across the sky, while interstellar dust creates the dark lanes that divide its glowing band. This dust, though almost invisible, plays a vital role in the galaxy's life. It absorbs starlight, re-emits it in infrared, and provides surfaces where simple molecules can form. Through this chemistry, new generations of stars are prepared, linking the processes of birth and decay across time. The Milky Way's spiral arms, such as the Perseus and Sagittarius arms, curve outward from a central bar that extends through the galactic core. This bar is composed of densely packed stars and gas rotating slowly, and influencing the movement of material across the inner galaxy. It acts as a bridge between the bulge and the outer disk, guiding gas inward, while stimulating star formation along its edges. The central bulge, a thick spheroidal concentration of old stars, surrounds Sagittarius A, the supermassive black hole that anchors the Milky Way. Although invisible, the black hole's gravity controls the orbits of nearby stars, some of which move so swiftly that their paths reveal the mass hidden at the center. Occasionally, as gas approaches the event horizon, it emits bursts of energy visible in X-rays and radio waves. Most of the time, however, the core remains tranquil, its influence expressed only through motion and balance. The bulge itself glows with the warm light of ancient suns that have endured since the galaxy's earliest epoch. Their steady radiation gives the inner region its golden hue, contrasting with the bluer tones of younger stars farther out. Surrounding this core, the thin disk spreads outward, flattening as it reaches the periphery. Here in the Orion Arm, where the Sun resides, the stellar density is moderate, allowing planetary systems like ours to exist in relative stability. The Sun's position, about 27,000 light-years from the center, lies within a quiet zone where radiation from the core is faint and gravitational disturbances are minimal. This region moves smoothly within the galactic rotation, orbiting the center at roughly 220 kilometers per second. The solar system oscillates slightly above and below the plane, completing one full orbit every 230 million years. During this vast journey, it encounters regions of varying density, passing through the thin clouds of interstellar gas and occasionally near star-forming complexes, though these transitions occur over spans of time too long for life on Earth to notice. Beyond the thin disk lies the thick disk, an older and more diffuse component containing stars that formed early in the Milky Way's history. These stars have eccentric orbits carrying them farther above and below the galactic plane. Their presence reveals how the galaxy assembled through mergers and accretion long ago. Above this thick disk, the halo extends outward in a faint sphere, populated by ancient globular clusters and dark matter. The halo's stars are metal-poor, meaning they contain few heavy elements, a sign of their primordial origins. Some clusters orbit far beyond the visible edge of the galaxy, moving in slow ellipses that take hundreds of millions of years to complete. Their light dim but enduring offers a glimpse into the galaxy's early structure. The halo's dark matter dominates the Milky Way's total mass, its gravity determining the orbits of the outer stars and maintaining the galaxy's coherence. The outermost regions of the Milky Way are not perfectly flat but slightly warped, bending upward and downward in opposite directions. This subtle deformation may result from interactions with smaller galaxies such as the Magellanic Clouds. These two companions visible from the southern hemisphere are irregular dwarf galaxies rich in gas. They orbit the Milky Way as satellites linked by streams of hydrogen that trail for hundreds of thousands of light years. Over time, their material flows inward, providing fresh fuel for future star formation. Other dwarf galaxies orbit more distantly, faint and diffuse remnants of systems already being absorbed into the Milky Way's halo. Their gradual disintegration leaves behind streams of stars, delicate ribbons that wind around the galaxy like faint echoes of past encounters. Such processes reveal that the Milky Way is still growing its shape, constantly refined by the quiet assimilation of its neighbours. In this way, creation and destruction coexist in perfect balance. The Milky Way also participates in a larger structure known as the Local Group, a collection of about 50 galaxies bound together by gravity. Among them, the Andromeda Galaxy is the largest and most significant companion. Observations show that Andromeda is moving toward the Milky Way at several hundred kilometers per second. In approximately 4 billion years, the two galaxies will meet their stars intermingling in a slow, majestic merger. Though vast in scale, this event will be gentle with few direct collisions. Over time, their spiral arms will dissolve into a single elliptical galaxy, and the legacy of both will live on in the merged system. Even now, faint tidal bridges of stars hint at this future, showing that the dance has already begun. Within the Milky Way itself, life continues quietly. Stars age, planetary systems evolve, and gas flows through the arms in an endless loop. Cosmic rays travel through magnetic fields linking distant regions with streams of high-energy particles. The galactic magnetic field follows the spiral structure, influencing how clouds collapse and how energy moves between them. Despite the complexity of these interactions, the overall effect is calm. The Milky Way functions like a vast clockwork, each component fulfilling its role in the slow mechanics of the cosmos. Its light, when viewed from Earth, is ancient but steady, crossing tens of thousands of years to reach the human eye. To look upon it is to see both history and continuity, a galaxy in motion that feels still an island of light adrift in the endless dark. The Milky Way endures as a symbol of cosmic equilibrium, its beauty arising from quiet motion, its stability from eternal change.